Welcome to our deep dive into the fascinating world of motion. In this chapter, we'll explore the fundamental laws that govern how objects move and interact. From Newton's groundbreaking principles to the everyday forces we encounter, understanding these concepts is crucial for anyone interested in physics or engineering. We'll start by laying the foundation with Newton's first law, then build up to more complex ideas like momentum, friction, and equilibrium. By the end, you'll see how these laws explain everything from a rolling ball to a rocket launch. Let's begin our journey into the laws of motion. Newton's first law of motion, often called the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and direction unless acted upon by an unbalanced external force. This principle explains why you need to apply force to start or stop moving objects. It's the reason why passengers lurch forward in a car when it suddenly stops. The law highlights the natural tendency of objects to resist changes in their state of motion, a property known as inertia. Inertia is all around us. Think about riding a bicycle. When you stop pedaling, the bike keeps moving until friction or another force slows it down. Or imagine a book resting on a table, it won't move unless you push it. Even in sports, a soccer ball remains still until kicked. These examples show how inertia affects both stationary and moving objects. Recognizing inertia in daily life helps us understand why seatbelts are essential in cars and why heavy objects are harder to start or stop moving. Newton's second law of motion provides a quantitative description of how forces affect motion. It states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. In simple terms, the harder you push, the faster something moves, but heavier objects require more force to achieve the same acceleration. This law forms the basis for understanding how vehicles accelerate, how athletes sprint, and how machines operate. Let's break down Newton's second law mathematically. The law tells us that force equals mass times acceleration, or F equals ma. This means if you know the mass of an object and how quickly it's accelerating, you can calculate the force applied. For example, if you push a 2 kg box so it accelerates at 3 ms2, the force is 2 kg times 3 ms2 equals 6, and this simple equation is a cornerstone of physics, used in everything from engineering to sports science. Newton's third law of motion is famously stated as, for every action there is an equal and opposite reaction. This means that whenever one object exerts a force on another, the second object exerts an equal force back in the opposite direction. This law explains why rockets launch, why you feel a kickback when firing a gun, and why jumping off a boat pushes it backward. It's a fundamental principle that governs all interactions between objects. Action-reaction pairs are everywhere. When you walk, your foot pushes backward on the ground and the ground pushes you forward. In swimming, your hands push water backward, propelling you ahead. Even birds flying use their wings to push air down and the air pushes them up. These pairs of forces are always equal in magnitude and opposite in direction, illustrating Newton's third law in action in our daily lives. Momentum is a measure of how much motion an object has. It's calculated as the product of an object's mass and velocity. The greater the mass or speed, the more momentum it has. For example, a moving truck has more momentum than a bicycle going at the same speed. Momentum helps explain why it's harder to stop a fast-moving or heavy object and why collisions can have significant effects. Law of conservation of momentum states that in a closed system, the total momentum before an event is equal to the total momentum after, provided no external forces act. This principle is crucial in understanding collisions, whether between cars or billiard balls. It means that momentum is not lost but transferred between objects, allowing us to predict outcomes in various physical situations. See how Newton's laws lead to the conservation of momentum. When two objects interact, Newton's third law tells us the forces they exert on each other are equal and opposite. Over the time of interaction, these forces cause changes in momentum that are also equal and opposite. As a result, the total momentum of the system remains constant, provided no external force acts. This derivation is fundamental to analyzing collisions and explosion. Pulse is the effect of a force acting over a period of time. It's calculated as the product of force and the time interval during which it acts. Impulse changes an object's momentum, such as when a bat strikes a ball or when airbags deploy in a car crash. The longer the force acts, the greater the change in momentum. Understanding impulse helps in designing safer vehicles and sports equipment. Relationship between impulse and momentum is direct. Impulse equals the change in momentum. Mathematically, impulse equals force times time equals change in momentum. This means that applying a force for a longer time results in a greater change in an object's motion. For example, catching a fast-moving ball with soft hands increases the time of contact, reducing the force felt and making the catch safer. Friction is a force that opposes motion between two surfaces in contact. It's what makes it possible to walk without slipping and what slows down moving objects. Friction can generate heat, wear down materials, and affect the efficiency of machines. While sometimes helpful, friction can also be a nuisance, causing energy loss and requiring extra effort to move objects. There are two main types of friction, static and kinetic. Static friction acts when objects are not moving relative to each other, preventing motion until a threshold force is reached. Kinetic friction, on the other hand, acts when objects are sliding past each other. Static friction is usually greater than kinetic friction, which is why it's harder to start moving a heavy box than to keep it sliding. Rolling friction occurs when an object rolls over a surface, like a wheel or a ball. It's generally much less than sliding friction, which is why vehicles use wheels instead of dragging. Rolling friction is crucial in transportation, making movement more efficient and reducing energy loss. However, it still exists due to deformation of surfaces and the rolling object. Friction can be reduced in several ways. Lubricants like oil or grease create a thin layer between surfaces, making them slide more easily. Using smoother materials or adding wheels and ball bearings also helps. In machines, reducing friction improves efficiency and extends lifespan. However, sometimes friction is necessary, such as for brakes or shoe soles, so it's all about finding the right balance. Equilibrium occurs when all the forces acting on an object balance each other out, resulting in no change in motion. This can mean the object is at rest or moving at a constant velocity. Understanding equilibrium is essential in engineering, architecture, and even sports, as it helps ensure stability and safety in structures and systems. Free body diagram is a simple sketch used to show all the forces acting on an object. By representing forces as arrows, these diagrams help us analyze situations and solve problems in mechanics. They're essential tools for students and engineers, making it easier to visualize and calculate the effects of different forces on an object. When an object moves on an inclined plane, gravity acts both down the slope and perpendicular to it. This creates a component of force that causes the object to accelerate down the slope. Friction and normal force also play roles, affecting how fast the object moves. Understanding motion on inclined planes is important in designing ramps, roads, and even amusement park rides. Pseudoforce appears when observing motion from a non-inertial accelerating frame of reference. For example, when a car suddenly accelerates, passengers feel pushed back, even though no physical force is acting in that direction. This apparent force helps us analyze motion from different perspectives, especially in rotating or accelerating systems. Newton's laws are fundamental to mechanics because they provide the basic rules for how objects move and interact. They form the backbone of classical physics, enabling us to predict and explain a vast range of phenomena, from falling apples to orbiting planets. Without these laws, our understanding of the physical world would be incomplete. Laws of motion aren't just theoretical, they have countless real-life applications. Engineers use them to design safer cars, athletes rely on them to improve performance, and architects ensure buildings can withstand forces. Even everyday actions like walking, driving, or playing sports are governed by these principles. Understanding them empowers us to make better decisions and innovations. Force and acceleration are directly linked by Newton's second law. When you apply a greater force to an object, it accelerates more, but if the object is heavier, it accelerates less for the same force. This relationship is crucial in designing vehicles, machinery, and even amusement park rides, where controlling acceleration ensures safety and comfort. When forces on an object are balanced, there's no change in motion. But if forces are unbalanced, the object accelerates in the direction of the net force. This concept explains why a parked car stays still until pushed, or why a soccer ball speeds up when kicked. Recognizing balanced and unbalanced forces helps us analyze motion in everyday life. Friction plays a vital role in sports. It allows athletes to grip surfaces, control balls, and stop quickly. For example, basketball players rely on friction between their shoes and the court, while soccer players need friction to dribble and shoot. Too much or too little friction can affect performance, making it a key factor in sports equipment design. In machines, friction can cause wear and energy loss, but it's also necessary for parts to function properly. Engineers use lubricants and special materials to minimize unwanted friction, improving efficiency and durability. Understanding how to manage friction is essential in designing everything from engines to household appliances. Friction affects us every day, from walking on the sidewalk to writing with a pencil. It helps us hold objects, drive safely, and even light matches. Sometimes we want more friction, like on icy roads, and other times less, like when sliding furniture. Learning to control friction makes daily tasks easier and safer. When two surfaces rub against each other, friction generates heat. This is why your hands warm up when you rub them together, or why car brakes get hot after stopping. While this heat can be useful, it can also cause problems like overheating in machines. Managing friction and heat is important in many industries. Over time, friction causes materials to wear down. This is why tires need replacing, shoes get holes, and machine parts require maintenance. Engineers design products to withstand wear or make them easy to replace. Understanding friction and wear helps us build longer-lasting and safer products. Lubrication is a key method for reducing friction and wear. Oils, greases, and even water can act as lubricants, forming a protective layer between surfaces. This not only makes movement smoother but also extends the life of machines and tools. Proper lubrication is critical in everything from bicycles to industrial machinery. Friction is essential for safety. It allows brakes to stop vehicles, shoes to grip the ground, and hands to hold objects securely. Without enough friction, accidents can happen, like slipping on ice or losing control of a car. Safety equipment and surfaces are often designed to maximize friction where it's needed most. Transportation systems depend on friction. Tires grip roads, trains rely on friction between wheels and rails, and airplanes use friction to slow down when landing. Engineers carefully balance friction to ensure vehicles move efficiently and stop safely. Too much or too little can lead to problems, so it's a key consideration in design. Friction always causes some energy to be lost as heat. This is why engines and machines are never 100% efficient. Engineers work to minimize these losses by using better materials, lubricants, and designs. Reducing friction saves energy, lowers costs, and helps protect the environment by making systems more efficient. Innovations in materials and technology have helped us control friction better than ever. From advanced lubricants to special coatings, these developments make machines run smoother and last longer. In sports, new shoe designs improve grip, while in industry, better bearings reduce energy loss. Innovation continues to shape how we manage friction. Reducing friction not only saves energy but also helps the environment. More efficient machines use less fuel and produce fewer emissions. Eco-friendly lubricants and materials are being developed to further reduce environmental impact. By understanding and controlling friction, we contribute to a more sustainable future. In space, friction is almost non-existent because there's no air or surfaces to rub against. This allows satellites and spacecraft to move freely, but it also means they can't slow down without using thrusters. Engineers must design systems that work in these unique conditions where the absence of friction changes how things move. Weather conditions can greatly affect friction. Rain, snow, or ice reduce friction on roads, making driving more dangerous. Engineers design tires and road surfaces to maintain grip in different weather. Understanding how friction changes with weather helps us stay safe and adapt to challenging conditions. Different materials have different friction properties. Rubber grips better than metal, while glass is very smooth. Engineers choose materials based on the level of friction needed for a specific task. This knowledge is used in everything from making tires to designing kitchen tools. Controlling friction is essential for precise motion. In robotics, too much friction can cause motors to overheat, while too little can lead to slipping. Engineers use sensors and control systems to monitor and adjust friction, ensuring smooth and accurate movement in machines and devices. Many everyday tools rely on friction to work. Pencils write because of friction with paper, scissors cut by gripping material, and screwdrivers turn screws by holding onto grooves. Understanding friction helps us use tools more effectively and design better ones for various tasks. Friction isn't just about work, it's also about fun. Slides, swings, and playground equipment are designed with friction in mind. Too much friction slows you down, while too little can be unsafe. Engineers balance these forces to create enjoyable and safe experiences for everyone. Artists use friction in their work, whether it's the drag of a brush on canvas or the resistance of a pencil on paper. Different materials and techniques create unique textures and effects. Understanding friction allows artists to control their tools and achieve the desired results in their creations. Friction is important in healthcare too. Medical devices like syringes, prosthetics, and surgical tools are designed to have just the right amount of friction for safety and comfort. Even the soles of hospital shoes are made to prevent slipping. Proper friction ensures better outcomes and patient safety. Nature uses friction in many ways. Animals rely on friction to climb, run, and grip surfaces. Tree bark, animal paws, and even fish scales are adapted to control friction for survival. Studying these natural solutions inspires new technologies and materials in human design. We've explored the laws of motion, from Newton's foundational principles to the many faces of friction. These concepts shape our world, influencing everything from technology and sports to art and nature. Understanding motion and forces empowers us to innovate, solve problems, and appreciate the science behind everyday life. Keep exploring and you'll find the laws of motion at work all around you.